Alright, today we're going to be multiplying polynomials, and we're going to be using something called the box method to help us organize our polynomials and ensure we are multiplying correctly. One of the first things that we need to remember, though, in multiplying, when we are multiplying polynomials, they do not have to be like terms to multiply them, but we have to remember that we need to add exponents when we're multiplying. So let's look at our first example. It is the distributive property. It is negative 2 times 2s squared plus 2s minus 4. So I've already drawn in a box. I only need it to be one deep because I only have one term outside. And then I need to divide it 3 ways because I have 3 terms on the inside. And I write those 3 terms along the top. What I have to remember here is this is 2s to the 0 power, because anything to the 0 power, anything that's just a number, anything to the 0 power is just 1. So negative 2 times 1 is just the negative 2. This is understood to be a power of 1. And then this one is s to the 0 power. So when I start looking at this, negative 2 times 2 is negative 4. S to the 0 power times s squared is s squared, because 0 plus 2 is 2. Negative 2 times 2 is negative 4. S to the 0 times s to the first is still s to the first, because 0 plus 1 is 1. And then negative 2 times negative 4 is a positive 8, and s to the 0 times s to the 0 is s to the 0, which is 1, and 8 times 1 is just 8. So our final answer is negative 4s squared minus 4s plus 8. So let's look at this example. This is one term times another term. So we don't necessarily need the box. What we need to remember is negative 4 times negative 7 is a positive 28. Z to the 4th times z to the 4th is z to the 8th, because 4 plus 4 is 8. So this is our final answer is just the 28z to the 8th. This first polynomial has 2 terms. This second polynomial has 2 terms. So it means I need to divide my box into this way, and I also need to divide it into this way. This polynomial either has to go across the top or down the side. It stays together. So 4d minus 4. It stays on the same side together. I cannot split it up like this. That is incorrect. Make sure it goes down the same side or across the top. So then that means what's in this polynomial has to go across the top. It goes together. So let's start multiplying. 4 times 3 is 12. D times d is d squared. Negative 4 times 3 is negative 12. That's d to the 0 plus d to the first is, times d to the first is d to the first. 4 times negative 3 is negative 12. D to the first times d to the 0 is d to the first. And then negative 4 times negative 3 is a positive 12. And now something happens here. Once we get our box, remember, we have to combine like terms. We have to put those together for our final answer. So once we multiply and get the numbers in the box, anything in the box that is a like term can be added together. So there's not any other d squareds. So I have 12d squared. I have a negative 12d and a negative 12d. They add together to give me a negative 24d, and then I have the positive 12. So this would be my final answer. This is another 2 by 2. So I can split my box into this way and then split it into this way. So this has to stay together. So I can put it across the top. It stays together. And then this polynomial has to stay together. So I can put it down the side together. 4 times 4 is 16. W times W is W squared. 4 times 2 is 8. And then I have the W. 4 times a negative 2 is a negative 8. And I have the W. And then 2 times a negative 2 is a negative 4. These are like terms because they're both single W's. So that means I'm going to combine them for my final answer. So I have 16W squared. I can't combine it with anything. There's no other W squares. 8 minus 8 is 0. So I'm actually left with no W's. And then I'm left with negative 4. So the answer to this problem is 16W squared minus 4. We have 2 more to look at. Let's look at the one that is a binomial times a trinomial. It's 2 terms times 3 terms. So I would split my box into one way, and then the other way I have to split it into thirds. This stays together, so this has to go down this side that was split in 2. And then this polynomial stays together. It has to go across the top where I split it into thirds. So C, this is an understood 1 in front. So 1 times 2 is 2. C times C squared is C cubed, 1 plus 2. 2 times negative 1 is negative 2, and we keep the C squared. 1 times 4 is 4. C times C is C squared. And that's a 1, and that's 1. 1 times negative 3 is negative 3. We keep the C. Negative 1 times 4 is negative 4. We keep that C. And then negative 1 times negative 3 is a positive 3. So now I have a couple of things to combine. I can combine these C squareds, they're like terms, and then I can combine these C's because they are like terms. So I have a 2C cubed, that can't combine with anything, and then a negative 2C squared plus 4C squared is a positive 2C squared, and then negative 4C plus a negative 3C is a negative 7C, and then I have that positive 3. So this is my final simplified answer for multiplying those polynomials. And then the last example we're going to look at is a special case. It is something squared. A lot of students want to do 9m squared minus 9, and that is incorrect. If we do the box method, think of what it means for 2 to be squared. That means 2 times 2. 4 squared means 4 times 4. So when I have a quantity 3m minus 3 squared, that means I am actually multiplying it by itself. So that means if I'm doing the box method, I'm going to split my box in 2, because this polynomial has 2 terms. That one has 2 terms. They just happen to be the same thing. So that means I'm going to put 3m minus 3 down the side, and I'm going to put 3m minus 3 across the top. So 3 times 3 is 9. M times m is m squared. Negative 3 times 3 is negative 9m. And then 3 times negative 3, that's negative 9, and we keep the m. And then negative 3 times negative 3 is a positive 9. So we can combine these terms right here. They are like terms. So my final answer is 9m squared. Negative 9 plus negative 9 is a negative 18m, and then positive 9. And that is the end of our examples of multiplying polynomials.